Sentiment analysis, also known as opinion mining, is a branch of natural language processing that identifies and extracts subjective information from source materials. Its main task is determining the attitude or sentiment, positive, negative, or neutral, expressed in written text. Businesses utilize sentiment analysis to understand customer attitudes and preferences. It is applied in diverse fields like social media monitoring, product reviews, and customer feedback analysis to improve products and services. Sentiment analysis generally involves classification of text into categories such as positive, negative, neutral, or sometimes mixed. This process can operate at various levels. Document level determines the overall sentiment of the document. Sentence level targets sentiment of individual sentences. Aspect-based identifies sentiments related to specific aspects or entities within the text. Each type involves different analytical depths and can provide different insights depending on specific business needs. Several methods are widely utilized for sentiment analysis. Lexical approach uses dictionaries to measure sentiment by comparing text against lists of positive or negative words. Machine learning approach uses labeled datasets to train classifiers, e.g., decision trees, support vector machines, to automatically recognize sentiment. Hybrid approach combines lexical and machine learning methods for enhanced accuracy and nuanced sentiment detection. Method selection typically depends on requirements for accuracy, flexibility, and resource availability. Microsoft Azure Cognitive Services offers powerful capabilities for sentiment analysis through its Text Analytics API. The service quickly identifies sentiment labels positive, negative, neutral, and mixed. Provides confidence scores to reflect the accuracy and reliability of predictions. Enables bulk analysis and real-time assessment to handle large data sets efficiently. This allows developers and organizations to embed robust sentiment analysis capabilities rapidly into their applications and workflows. To implement Azure Sentiment Analysis, users should first create a text analytics resource in the Azure portal. Steps include logging into the Azure portal and creating a new Cognitive Services resource, obtaining an API key and endpoint from the resource dashboard, setting appropriate permissions and resource locations according to security standards and geographic requirements. The resource is then ready to integrate into custom applications using appropriate SDKs and API specifications from Azure's documentation. Azure Text Analytics API can be integrated using REST API endpoints or SDK libraries for various programming languages, such as .NET, Python, JavaScript, Java. Typical API workflows include authenticating API requests via API keys or Azure Active Directory, sending text data in JSON format via POST requests, receiving JSON output documenting the sentiment label and corresponding confidence score for each analyzed document or sentence. Python is a widely used language for integrating Azure Text Analytics. Python from Azure.ai. Text Analytics import Text Analytics client from Azure.core. Credentials import Azure Key Credential equals Azure Key Credential. Client equals Text Analytics client, endpoint equals credential, documents equals I love this product. This is the worst experience ever. Response equals client.analyze core sentiment documents for doc and response. Printf sentiment. Doc.sentiment scores. Doc.confidence scores. Azure Sentiment Analysis provides structured outputs, typically including overall sentiment, categorized as positive, neutral, negative, or mixed. Confidence scores, numerical scores between 0 and 1 indicating the probability of accuracy of the sentiment assigned. Sentence-level sentiment, separate sentiment scores for each sentence in an analyzed batch of text. These outputs facilitate granular insights into customers' or users' attitudes and feedback within texts. Evaluating Azure Text Analytics sentiment predictions involves considering confidence scores. Higher confidence scores, near 1.0, reflect clear sentiment classifications. Error analysis. Reviewing instances of incorrect sentiment labeling helps refine settings or guide manual classification enhancements. Comparative analysis Comparing API outcomes to labeled datasets or business expectations helps assess accuracy and internal consistency of sentiment analyses. Common challenges associated with sentiment analysis include subjectivity, ambiguity, and nuanced language make accurate sentiment identification difficult. Context detection. Misinterpretation of idiomatic expressions or sarcasm can lead to erroneous sentiment classification. Language and dialects. Sentiment models trained on specific languages or dialects may struggle to accurately classify text from unfamiliar linguistic contexts. Awareness of challenges enables developers to anticipate problems and improve NLP models accordingly. Implementing sentiment analysis in Azure effectively often involves best practices, such as using diverse and comprehensive training datasets to increase classification accuracy, continuously monitoring and retraining models to adapt to linguistic shifts or changing contexts, performing regular error analyses to identify systematic errors or biases. Adherence to best practices ensures higher accuracy and robust operation in real-world scenarios. Sentiment analysis finds extensive real-world applicability across various sectors. Customer service, assessing customer satisfaction and service quality. Social media monitoring, tracking public opinion and trends relevant to brands or events. Market research, gaining insights from customer reviews and feedback to improve products or experiences. These applications highlight the intrinsic value of sentiment analysis enhanced by Azure Cognitive Services in commercial and social contexts.